Hi there, I'm Alex Kotopoulis. I'm part of the GoldenGate product management team here at Oracle. And our talk today is part of a larger series on the topic of data mesh provided by our GoldenGate group within the Oracle database team. We cover data management and integration of streaming live real-time data. You don't have to worry if you didn't see the other parts. This session about stream data processing stands by itself without much context from the other part. To give a quick summary of part one, we cover what the data mesh is and how it can help you as a developer. Data mesh has different definitions in the industry, but all agree that it's a methodology that puts data at its center and treats it like a product that is provided to consumers within your organization, and maybe your partners or even your external customers. A product is planned by someone who acts like a product manager, and it's created and managed in a more decentralized manner, both organizationally and technically. So we are getting closer to the business groups that actually produce the data, rather than a centralized service provider. Data products can be raw data, unrefined big data, to normalized and curated data, up to aggregated data, predictions, and even decisions made from the data. And importantly, this data can be provided in real time as events rather than accumulated data sets, as data is usually created event by event and transaction by transaction rather than a complete table. These real-time data products are what we will be focusing on. Part two is focusing on how you as a developer can get transactional data in real time by capturing and forwarding transactions as they are committed in a transactional system, such as the Oracle database. You can use these captured transactions to feed microservices, local database copies, and synchronize two-to-many replicas of databases to increase availability, performance, and decentralization. Oracle GoldenGate provides this functionality not just for Oracle DB, but also for other relational and non-relational databases, also data lakes, object stores, or even event platforms such as Kafka. And as you will see, the Oracle GoldenGate transaction replication fits very well as a feeder into stream processing that we will talk about today. So coming back to stream processing, what is it good for? How can developers and their organization take advantage of it? Let's start with an example that we will demo. In our company, MovieStream, which you might have seen in other database demos, we are working with a national jewelry chain in the United States. And we would like to target specific customers when they select a movie and invite these customers to an exclusive event where they can purchase merchandise. We need to limit these customers to those who might be in the market for jewelry. For this, we want to use information on what kind of movie was chosen and other demographic information to narrow the choice of customers who will get the offer, and to limit it to specific regions that have nearby retail stores. This is a summary on how we can accomplish this complex goal. Whenever a movie is selected, it causes a transaction in the autonomous transaction processing database. And we will capture this event with the OCI GoldenGate service. We are listening to the stream of transaction in GoldenGate Stream Analytics, and each event will first be enriched with the customer and demographic data that we store in an autonomous data warehouse or ADW. Then, based on the location of the customer, we filter specific geographic regions that we have defined. Each event is then scored through a machine learning model we run in the ADW. And this model was trained on training data with movie types and demographic features. We filter scored events based on a threshold score, and all selected events are used to send the promotion offer in OCI streaming. And we also store the offer info for later analysis into a data lake. So let's take a look at our demo. In this demo, we want to perform real-time decisions based on the stream of user activity for our MovieStream application. So users who select a movie should be extended an invitation to an exclusive event by a national jewelry chain based on their geographic location, their movie selection, and their likelihood to purchase jewelry. So as a developer, I know that stream processing at scale is one of the more challenging tasks. So most streaming platforms require to write complex code in languages such as Scala or PySpark. our goal is to make developers more productive and allow them to collaborate with other and less technical roles. So in the last demo, we saw the use of OCI GoldenGate in order to replicate data from the MovieStream OLTP database. So in this demo, we'll use the same environment. So we'll go to GoldenGate on OCI. And this time we will also use an extract in GoldenGate replication, and we will create an additional deployment in order to do stream analytics. So you see the deployments here in OCI GoldenGate. We'll go to connections. We also have selected connections for a number of the different data sources and targets that we're going to use. And we'd like to create a deployment for stream analytics. So we're creating a new deployment. You've seen this in the other demo before. We're going to use the same concepts, this time for stream analytics. You can select the amount of OCPUs you would like to assign to this deployment. You can enable auto-scaling, which will enable you to use up to 3 times the amount of OCPUs based on need. You pick a subnet, you set your license type. You can decide whether you want to use a public or a private network. And then on the next page, you have a selection of different technologies for GoldenGate. In this case, we want to use GoldenGate Stream Analytics, and you provide a new instance name and your administrator credentials in order to set up this new deployment. So after you set up your deployment, you'll press create. We'll skip this in this case because we already have a deployment. Let's take a look. We have the Stream Analytics deployment. And here we have assigned a number of connections in order to be able to set these. These will be used in the Stream Analytics environment itself, and they can be shared between replication and Stream Analytics. And you can open the Stream Analytics console where you can define and run and administer your streaming pipelines. As we're looking at the catalog, you see the different object types that Stream Analytics has. And everything revolves around pipelines, which is the most important object type, where you get real-time streams, one or more, you will process them, and then you write your results to one or more targets. You also have streams, which define the input and the metadata which comes into pipeline. You can do lookup references, you can add predictive models and geofences, which are used for geospatial processing, and the connections, which are automatically populated from OCI GoldenGate. So let's take a look how pipelines work and how we can create one. And before we do that, let's also see how we can actually capture from GoldenGate replication. So for this, we have the concept of the GoldenGate change data, and we have here the activity stream capture. This will automatically connect to an extract that was already created by the previous demo. So we set which kind of extract, which kind of change stream we want to connect to, and then it will automatically set up all the connectivity to GoldenGate and will provide you with the data that you will use as an input to a pipeline. So as you have this change data set up, you also set up a stream, this GG activity stream. This will provide you with a steady stream of events that are coming through the changes to your source database. Now let's create a new pipeline. So we're opening up a new pipeline. All you have to set up is you give the pipeline a name and you select which kind of stream you want to take as input. So once you've done that, that's all you have to do in order to create a running pipeline. And that's an important thing to see here. You don't have to write code. You don't have to go through a compile and deployment process. Your pipeline is automatically deployed in draft mode, so you see the data coming in from your streaming sources. And as you're building up the pipeline piece by piece, you will see how the data is transformed. You can immediately spot any kind of errors and issues in your pipeline as you go forward. And this is a great way to develop pipelines. You also have the option to write code if you want to. You can write or CQL, continuous query language code, as part of these individual steps. So you have a choice whether you want to stay high level and quickly create pipelines, or if you want to become more detailed and write specific pipelines based on your queries. So here, as a next step in our pipeline, we'd like to join with a lookup source. You can use a query step here, and a query step enables you to join, to select, and also to filter and to summarize your data. In this case here, we add an additional source, which is the customer lookup table. And then you have to set the correlation condition, which you can consider like a where clause in a SQL statement. So in this case, we join based on the custom ID. And immediately after you set the correlation condition, you'll see that it's automatically deployed in draft mode, and you see your events changed on the bottom. You see a color-coded output of the different columns, green coming from the streaming events and orange coming from the lookup source. So as you go through here, you will add more steps. We can add a pattern step here. And this is important, this pattern stage. In a lot of cases, you have to write complex code in order to do specific correlations, specific joins, which can become quite involved. And we have captured the most common correlations, the most common patterns that you would do in real-time streaming, and combined them in a pattern library. So for example, you see patterns based on trend, where you can see changes in behavior, you can see outliers, you can see specific sequences of events, for example, A followed by B. If you have an open something event, is the corresponding close event coming within a certain time window? This is something that you can check here as part of these patterns. You can also transform your data. You can pivot and split. You can do spatial patterns where you work based on geographical information such as your speed, your direction, your relationship to other events. You can check your state, you can enrich your data, you can look out for missing events. A lot of different patterns that we provide that are designed to make you more productive. If you want to, you can write your own code, but you can also use your pattern library in order to pick what already exists. So this was a quick introduction into how you can write a pipeline. We'll switch gears and we'll jump to a pipeline that has already been created and see how it works. We have written the movie promotion pipeline, which is performing the real-time decisions as we described earlier. You can see at the beginning it is like the pipeline that we just created, but in this case we also joined with two more sources. So we're not just joining with customer, we're also joining with genre and movie. So you see on the bottom we have color-coded 4 total inputs, and you see the data coming in. So it's again deployed in draft, and we have correlation conditions, and you see different inputs here. You see the different columns here. You can actually perform data wrangling right here. You can remove columns, you can change columns, you can add computed columns here. And as you have now your enriched data, the next step we want to do is go to a geofence. And in the geofence, we will perform the selection based on the region that the customer is in. And for this, we have defined a geofence outside of our pipeline that can be used. And we'll take a look at this geofence. It's called promotion area, and we'll see polygons that define different areas here, which is the West, Texas, Northeast, Chicago area, as well as the Southeast. And we'd like to quickly add another promotion area. In this case, we want to add Virginia. So you can draw a polygon here to define your Virginia area. You can do this either in this editor. We also allow polygons to be read from within the database if you have a lot of polygons, you want to make it scalable. So you have these two options. So as you edit another region, this is automatically added, and we will use this within our movie promotion. As you can see on the right, we are referring to this promotion area geofence, and you can also see visualizations, how the incoming events distribute on these different regions. And we only filter out the events that fit into a given region, and we only capture the events that are entering a region. You can also specify if you want to enter and leave a region, if you're close by to a region, if you linger for a certain time period in a region. So this geofence has other capabilities that we're not using in this particular pipeline. You can see on the right side a few new columns that have been added, so you can see the place name that each event falls into. So we've done that. We're now doing a few more preparation steps, and then we want to score based on a machine learning model. And this machine learning model we have created within Oracle Machine Learning, OML. So the next step is that we're going to switch to OML and take a look at this model. We have defined it as an AutoML experiment. So we've defined this movie promotion experiment. We have trained it with data from our MovieStream, and we want to score the likelihood of a certain customer buying jewelry based on a movie. So we've done that. So see on the right hand side, after the score ML stage, we get a scoring number. The higher it is, the more likely the user is to react to an offer of jewelry. So in the next step, we also filter these numbers. We want to have set a threshold greater than 0.05. If it passes this threshold, we determine this user should get an offer for the jewelry promotion. And in this case, we can also see a summary. We can see how many users are reacting, what is their relationship to their income, what are the genres that are being picked by our algorithms. So you'll see in this case we have romance and reality TV. As more events are scored, you'll see a change. So this is real time. You see the score by income, and this can be used both by the developer to validate immediately if their code is as expected, and it can be used later as developers work together with analysts and other workers to maintain these pipelines, change specific parameters in these pipelines. So it's not just the duty of the developer. The developer can delegate certain functions to other business specialists to maintain the pipeline and keep it running and get information from it. This wouldn't be possible in that way if it was all hidden within code. So this gives the additional benefit of developers to focus on creating new pipelines and delegate business concerns to the right audience. So in the end, we are sending out the offer into streaming, into OCI streaming, and we're storing the information in a data lake for further processing, for further analysis. So what you've seen here is how quickly you can create and use a pipeline in order to make streaming real-time decisions from our MovieStream application. Thank you. To conclude what we have just seen, there are areas where stream processing has helped in our MovieStream example. We can respond instantly to any user and application actions based on transactions or events that are directly sent to a streaming pipeline. We can augment the main application with additional actions that might be temporary or spontaneous, such as campaigns or responding to threats or fraud. The interactive UI helps with quickly developing these pipelines based on immediate needs. Within the pipeline, we can standardize and prepare data by converting it, enriching it with additional data from other sources, or filtering data or correlating it with other events. We can also apply decisions made with machine learning scoring in our real-time events. We can also apply rules and patterns to analyze and categorize events to detect situations we would like to act on. Based on what we have found using machine learning and patterns, we can then trigger alarms and events or directly initiate action. For example, lock a user if there's an indication of fraud. And finally, we can store any results of our pipeline for later analysis, making this a real-time ETL where information is processed and stored in a data warehouse or data lake. A big part of Oracle Stream Analytics is that it provides an interactive no-code to low-code environment. We do provide custom stages to enter continuous query language or SQL or perform processing in Java. So if you want to code, there are opportunities. But overall, you can quickly develop pipelines for standard situations. Compare this to other streaming environments such as manually coded Spark streaming, Flink, KSQL, or others. It forces you to code complex logic that is hard to understand, maintain, and service. This low-code environment makes it easier to maintain the pipelines by the eventual operators and keeps you as a developer free to create more content and solutions. For example, in consulting situations, we have found that it's preferable that the deliverable is self-explaining and easy to maintain by the target team, rather than having a black box that the consultant needs to service on a perpetual basis. Well, some consultant would love that. Anyway, in a corporate environment, this gives more power to decentralized teams. And this is one of the tenets of data mesh. Technical business users can understand the pipelines and make modifications such as configuring rules, and they can even create new pipelines. Oracle Stream Analytics provides different ways to automate provisioning and setup. As part of our OCI GoldenGate framework, Stream Analytics can run on a fully managed environment similar to autonomous services. We manage resources, patching, scaling, and maintenance. You can use Terraform, Chef, Ansible, or other configuration management tools, or directly call our REST APIs, or, for example, OCI CLI to set up and manage your environment, provision deployments, import or create streaming pipelines, or observe and monitor the health of your deployments. In the next few slides, we will talk about the Stream Analytics architecture. Like GoldenGate, we provide Stream Analytics in multiple formats that enables you to deploy it in various environments. We provide an installable distribution for on-premise or third-party cloud application, an OCI marketplace offering as a user-managed cloud solution that can be metered by use, and as a latest solution, a fully managed cloud-native service based on the OCI GoldenGate framework. So let's take a look at our base architecture. Stream Analytics provides its front end and control plane through an application that internally runs on a Jetty app server. This app server controls all design time activity and stores metadata in a database that can be Oracle or MySQL. When a pipeline is run, it automatically creates a Spark application that is then deployed in a distributed manner on a Spark master node and multiple worker nodes. The Spark application also uses our SQL query engine that provides shared memory and common checkpoints to enable exactly once processing. We also use Kafka as an internal communications channel, as an event platform for input and output. This environment is inherently scalable and redundant, allowing for high availability. The fully managed OCI GoldenGate Stream Analytics service is hosted and managed by Oracle and provides you with an easy-to-deploy and auto-scaling environment where you only pay for the resources that you actually use. It follows the architecture that you saw on the previous slide, but it's transparently managed by us. The actual architectural setup are Kubernetes pods that are automatically managed and scaled. But this is fully transparent to you. Instead, you can focus on the developer tasks, such as DevOps actions, pipeline development, and integration with sources and targets, as well as GoldenGate replication. At the same time, you can collaborate with analysts and business users who can use this for reporting dashboards, live charting, as well as configuration and maintenance of business parameters and logic. By providing different distributions for on-premises third-party cloud, as well as managed and unmanaged OCI cloud, you can create a true hybrid cloud and multi-cloud environment where data from multiple clouds is combined together. We have various customers and use cases operating in multiple clouds and bridging event system databases and object stores across different clouds and regions. The distributed nature of Oracle Stream Analytics even lets you run the application in one cloud and the underlying processing environments such as big data and Spark in another cloud. This makes you more agile and less dependent on one particular vendor. Another area of deployment are edge use cases, which are popular both in government and defense applications, as well as civilian use cases such as telecommunication and oil and gas exploration. Oracle Stream Analytics works on the roving edge infrastructure, or ROVA, allowing it to collect and process data in a semi-connected, low-bandwidth fashion or a fully disconnected fashion. This can be in an edge environment, such as planes, ships, or remote locations. Stream Analytics can use Oracle's cloud capabilities while it is disconnected and feed connected results back once connected again. To conclude, these are the top 5 differentiators. First, a no-code, low-code environment that lowers the bar of entry for everyone. As a developer, you might think, I want to code. Nothing is too complex for me. But even then, there are various benefits, such as the ability to easier pass off ownership of your results to others, such as analysts or domain-specific teams. It enables collaboration, so as a developer, you're not stuck with permanent maintenance, but can focus on the next project. We provide an industry strength performance and scalability, allowing you to handle various loads of incoming volume, and a full feature set to cover all kinds of use cases and event processing requirements. And this is particularly true for a pattern library, which simplifies stock situations such as event matching, pattern detection, machine learning, or geospatial situations. By having ready-made solutions for these advanced cases, you can be more productive in solving more and more complex use cases. Our new fully managed OCI GoldenGate Stream Analytics simplifies deployment and management, and it frees you from routine tasks such as backup, patching, and resource maintenance. It also allows you to be agile and scalable to quickly set up new solutions with unlimited bandwidth. Finally, we maintain an open architecture that allows you the choice between multi-cloud, hybrid cloud, and an or on-premises deployment. This is at the heart of the data mesh idea and maintains the freedom for you to run your payloads anywhere you want. I thank you for your time, and here is more information about where to learn about Oracle GoldenGate Stream Analytics and to try it yourself. And you can use these resources here in order to learn more, to try out the Autonomous Database and GoldenGate for free using these resources. So thank you for your time.